Speed, velocity, acceleration, reading. I can differentiate between speed, velocity, and acceleration. Your starter reads, looking at the animation, is this an example of balanced or unbalanced forces? List all the forces you see. Justify your answer. So let's talk about whether these forces are balanced or unbalanced. Since the man is changing his motion, we're going to say that these are unbalanced forces because we can change his speed as well as his direction. The forces acting on this person is going to be friction, gravity, and you could also even talk about the car experience. Perhaps it's traveling at a constant speed, then when it hits the brick wall, it changes its speed. It also changes its direction. Let's practice. Speed. Motion is a change in position relative to another object. How fast an object is moving is called speed. Speed is how far something travels, its distance, in a given amount of time. The formula for finding speed is speed equals distance divided by time. The unit used for speed is meters or kilometers, that's the distance, and seconds or hours for the time. It looks like this, units meters per second or kilometers per hour. Let's practice. Velocity. Sometimes it's important to know the speed and direction of an object when an object is traveling. Velocity is the term used when referring to the speed and a direction. So you might say the car is traveling 50 kilometers per hour north. Vectors can be used to show the direction of an object's motion. Let's practice. Acceleration. When a force is applied to a moving object, the object can speed up, slow down, come to a stop, or change direction. When a force changes the speed, direction, or both of an object, we're changing the velocity or the object. A change in velocity is called acceleration. This is the change in velocity over a given period of time. The formula for acceleration is acceleration equals velocity divided by time. An object falling to Earth is subject to a change is acceleration of 9.8 meters per second squared due to gravity. Examples of acceleration are stepping on the brakes or slowing down, pedaling your bicycle faster or speeding up, or a change in direction. Activity. Watch the video for review.
Thanks for stopping by. I'm Virgil Ricks, and this is 2-Minute Classroom. Today we're talking about motion. Specifically, we're talking about speed, velocity, and acceleration. And let's clear up a few things right off the bat. First of all, speed and velocity are different, and acceleration is much more than just speeding up. Speed is the rate at which something changes its position. It's represented as distance over time. Miles per hour, kilometers per hour, meters per second, these are all examples of the units for speed. So if you're driving in your car at 72 miles per hour, then that's your speed. In fact, it's your instantaneous speed, or your speed in that exact moment. If you get to the end of your trip and realize that it took you 2 hours to drive 120 miles, then your overall speed was 60 miles per hour. And this is also known as your average speed. Velocity is a lot like speed, except for one important difference. It's a vector, which means it has a direction attached to it. So while your speed may have been 72 miles per hour, your velocity was 72 miles per hour east, or 72 miles per hour towards the beach. There just has to be some direction attached to the speed to make it a velocity. With that knowledge in hand, you're now ready to understand acceleration, which is simply the rate at which velocity changes. It's represented as distance per time, or distance per time squared. For example, meters per second squared are common units for acceleration. Anytime you change your velocity, you are accelerating. That can be speeding up or slowing down, which is also known as negative acceleration. But direction is also a component of velocity. So when you change your direction, even if your speed doesn't change, you are accelerating. Does that blow your mind? Alright, let's recap. Speed is the rate at which something moves, distance over time. Velocity is speed with a direction, so distance over time with a specific direction. And acceleration, the king of them all, is distance over time squared, or the rate at which velocity changes. So whether you're speeding up, slowing down, or changing directions, you're changing your velocity and thus accelerating. Science is so cool. I hope you enjoyed this.
For our activity, we're going to drag the boxes to the scroll that correctly define the term. So as a activity, we just watched a video on speed, velocity, and acceleration. Speed is how fast or slow an object is moving. It goes distance and time. So we want to find some examples of speed. So we know speed is distance and time. Let me minimize. And I think if I present, I will be able to drag and drop that way. One moment. So speed is going to be distance and time. A ratio of distance an object moves to the amount of time the object moves. 90 kilometers per hour. Kilometers is your distance and hour is your time. Okay, speed in a specific direction, no. Change in velocity over time, no. 300 meters per second, no. Bolt slowing down to make a turn, no. 25 meters per second west, no. Speed up, slow down, or turn in a different direction, no. Alright, let's see if we can find examples of velocity. Remember, velocity is speed with a direction. Okay, so speed in a specific direction is a good definition. Uh, 25 meters per second west is a good example because this is speed with a direction, north, south, east, or west. Okay, I think that looks good. Let's go to our acceleration now. Acceleration is when we're going to change our speed or change our directions or change our speed and direction. So, change in velocity over time, yes, because we would be changing our direction over time. 300 meters per second, that would be meters per second squared. It's an example of acceleration. To speed up, slow down, or turn in a different direction. A boat is slowing down to make a west turn. Slowing down is when you are accelerating because you're changing your speed. Okay, speeding up, you're changing your speed, so you're accelerating. For our connection, we're going to read each statement carefully and use the pictures to identify the statement as speed, velocity, or acceleration, and then justify. Marnock butterflies fly 12 meters per hour south when they migrate. So here 12 meters per hour, that's our speed, but they're giving us a direction with our speed. So the monarch butterfly is an example of velocity because we have speed with direction. A bowling ball rolling 1 meter per second. So here we're just having the speed of the bowling ball. So the bowling ball is an example of speed because the units are meters per second. A roller coaster traveling in a loop. So if we look at this roller coaster, we understand it's going to be changing its direction, don't we? When it goes up, then down, west, east. So the roller coaster is an example of acceleration because we're changing our direction. We could also be changing our speed as we go down and up hills. The greyhound dog can run about 40 miles per hour. So 40 miles per hour, that's an example of speed. So the greyhound dog is an example of speed because of the units mile per hour. A person biking 12 meters per hour northwest. This is an example of speed with a direction. So a person biking is an example of velocity because we have speed with direction. A football just after being kicked. So a football being kicked is an example of acceleration because we're increasing its speed, and then when gravity pulls it down, we could be decreasing our speed. So the football being kicked is an example of acceleration because we're increasing our speed or decreasing our speed. The road runner runs down a path 20 miles per hour. So 20 miles per hour is just an example of speed. So the road runner is an example of speed because of the units mile per hour. A trip from Austin to Dallas traveling 65 miles per hour north. So 65 miles per hour north is an example of speed with direction. The trip is an example of velocity because there is speed with direction. A person parachuting at 9.8 meters per second squared. If we look at the units meters per second squared, this is an example of acceleration. A person parachuting is an example of acceleration because of the units meters per second squared. A hummingbird will fly 3.5 meters per second. So 3.5 meters per second, that's just an example of speed. The hummingbird is an example of speed because of the units meters per second. Star test question for our exit. A meteor moving 468 kilometers per minute traveling in a south to north direction passes near Earth in 2013. Because the meteor was only 45 meters wide and was 27,700 kilometers above Earth's surface, it was not visible without the aid of a telescope. Which statement best describes the meteor's motion? So if we have the meteor moving at 468 kilometers per minute, that's its speed, 468 kilometers per minute. And we are given a direction, south to north direction. If we look at our answer choices, answer choice A is velocity was 7.8 kilometers per second. Now, these units are kilometers per second. Up here, our meteor is going kilometers per minute. So to change this speed into kilometers per second, we would have to take 468 divided by 60 seconds to get kilometers per second. So 468 divided by 60 seconds would be 7.8 kilometers per second. And the meteor would be going northbound because it's going south to north. Here it's giving us an answer choice of acceleration of 468 kilometers per second squared. Here it's not giving us acceleration, it's giving us the speed of the meteorite. Then it says its speed was 468 kilometers per second northward. No, because our answer up here is 468 kilometers per minute. Again, we had to change this number into seconds by taking 468 kilometers per minute and dividing it by 60 to get 7.8 kilometers per second.